Question 2. Aqueous propanoic acid reacts with carbonates and alkalis. Write the full equation for the reaction of aqueous propanoic acid with sodium carbonate, and then write an ionic equation for the reaction of aqueous propanoic acid with aqueous potassium hydroxide. We've got two separate reactions going on. Now, there appears to be a blind spot with some A-level students when it comes to writing reactions involving carboxylic acids. And it's a bit strange because a carboxylic acid is just an acid. They're weak organic acids, but they behave like any other acids would do. Okay, an acid plus a base makes a salt and water. An acid plus a carbonate makes a salt plus water plus carbon dioxide. An acid plus a metal makes a salt and hydrogen. All the same type of reactions, the same things happen with carboxylic acid, so you treat them no differently. All you've got to remember is that the acid, the hydrogen that gets removed, that gets dissociated when the carboxylic acid breaks down is this one. So when you form a salt with the carboxylic acid, it's the H part of the COOH that gets replaced with the metal ion. And that's the only trick. And you've got to remember the charge on the carboxylate ion here, regarding how many carbons you've got, that's why I've called it carboxylate, the charge on this is always -1 because a hydrogen ion is +1. And you can see there's a 1-to-1 ratio between the carboxylate and the hydrogen ion. So you treat this as a minus ion, and when it comes to writing formulae, it's no different to any other inorganic acid. Okay, you balance the charges, you write the formula. So what's going on? Write the full equation for the reaction of aqueous propanoic acid with sodium carbonate. Okay, so propanoic acid, C2H5COOH, reacted with sodium carbonate. Now, be careful, sodium carbonate is Na2CO3. A carbonate is a 2- ion, sodium is 1+, so you need to cancel out, balance your charges. Na2CO3, very common mistake. So propanoic acid plus sodium carbonate, acid plus carbonate makes a salt, water and carbon dioxide. Let's put the obvious ones in first then, water and CO2. So it's what is the salt going to be? Now, as I've just said, this hydrogen here, this is the proton, this is the hydrogen ion that will be dissociated when the carboxylic acid dissociates. This, therefore, I'm calling your acidic proton. This is the terminology I've always used. Whether it's right or wrong doesn't matter, but that's the hydrogen ion that's going to be removed and therefore replaced with the metal ion to form your salt. If you think about how you define a salt, okay, it's formed when the hydrogen ion from an acid is replaced by the metal ion or by the ammonium ion. In this case, we've got sodium present in the sodium carbonate, so my metal ions are Na+. So my sodium ion is going to replace the hydrogen ion here. So my salt will be C2H5COONA. All right, 1+ charge on the sodium, 1- charge on the carboxylate, in this case, well, specifically the propanoate ion here, so the two will cancel out directly. Now you balance it like any other equation. Never forget, always remember, never forget to balance your equations. So I've got two sodiums here, two there. I'm going to need two of those, and therefore I'm going to need two of those, and there's my equation balanced. Okay, there should be no reason why any A-level student can't write a simple equation like that. Question 2, write the ionic equation for the reaction of aqueous propanoic acid with aqueous potassium hydroxide. Now, on the face of it, when you look at this question, you think, oh my goodness, how do I do that? And then you stop when you think, and you think about what you learned about acids and what you learned in particular about neutralization in your first year of A-level. Okay, all neutralization reactions, all acid and alkali reactions, both in the same condition, same physical state, simplify down to the same equation, the same ionic equation. H plus OH minus gives H2O. That is it. That is the equation for that, the ionic equation for that reaction. All you're doing is removing all the spectator ions that would have been present. Okay? Think about it. We've got potassium hydroxide is KOH. Okay? So we'd form potassium propanoate. So C2H5COOK. So the potassium ions will cancel because they're the same. They haven't changed. They're both aqueous. They're present on both sides. Okay. Likewise, the propanoate, the carboxylate ion, is present on both sides in solution. They cancel down. So you're left with just that. Simple as that.